Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izzati binti Muhammad Roslan and my matric number is 1712466. I am final year finance STEM student of civil engineering. I would like to present my final year project, which is about the effects of cohesion and angle of friction values on slope supported by soil nailing. Basically, I have divided my presentation into 5 main parts, which are introduction, literature review, methodology, results and discussions, as well as conclusion and future work suggestion. First, what is slope stability? Slope stability refers to the ability of inclined soil to resist or encounter the movement. As time passes by, a stable slope can be unstable because of the site condition changes or problems arise regarding the surrounding, and it can lead to mass movement. Nowadays, failure of slopes in Malaysia has been increasing year by year, and they result in huge losses to the respective locals. The impact of a landslide can be extensive, including loss of life and destruction of infrastructure. In addition, the failure of slope depends on the type of soils, seepage, and pore water pressure. To overcome the failure of slopes, there are some parameters that need to be considered in designing the slopes. Soil conditions at the site must be checked properly, and the type of soils need to be identified so that the laboratory test can be done. There are design parameters that can be provided from the test. Then, the data will be used to evaluate and do analysis regarding the condition of soil. Other than that, there are some remedial measures that can be used to treat unstable natural and artificial slopes such as soil nailing, rock, and soil anchors, as well as drainage. These kind of practices can be used in order to increase the factor of safety of the respective slopes. Basically, the purpose of this study are to evaluate the effects of different friction angle and cohesion of the soil based on the slope W program. Second, to identify the factor of safety of the slope by using different diameters of soil nail. And third, to analyze the slope stability and validate the sensitivity as well as the responsiveness of selected design parameters. The studied parameters include the cohesion and friction angle values of the soils, soil nailing length, numbers of soil nailing, and the bond diameter of the nails. Next, in terms of literature review, there are opinions from the existing articles, journals, and researches that are related to this topic that have been studied, such as the causes of slope failure, as shown in the table. There are 3 engineering classifications of human errors, which are design, construction, and maintenance errors. The description of the errors are described in Table 1. In order to overcome these errors, the design slope must satisfy the requirements and criteria that have been published in the manual by specific organizations such as Jabatan Kerja Raya JKR. For methodology part, this flowchart shows the process of this analysis is being carried out. Firstly, that study through research is needed to identify all of the information and requirements needed for this project. Secondly, data needed for the analysis will be collected from the previous research. Then, the value of cohesion and friction angle will be extracted from the collected data. This data will be used to conduct the analysis of slope stability. Next, the slope will be analyzed by using slope W program to generate the FOS of the slope. In this study, the slopes that have been analyzed are using soil nailing technique as the reinforcement. In order to determine the safety of the slope, the factor of safety should be more than 1.5. Next, this is the steps on slope stability analysis by using the GeoSlope software. The figure simplifies the procedures and techniques used in this study. In this paper, the type of analysis will be verified as Morgenstern price method. Then, the FOS of various slopes for different values of cohesion and friction angle which are supported by soil nails will be evaluated. Initially, the slope is analyzed with different soil types, which are gravel, silty clay, and clay, without the presence of any external destabilizing forces. After that, the slope is analyzed by including the water table and surcharge effects. Then, to make the slope stable, it is analyzed by using soil nailing technique. The length, spacing, and bond diameter of the nails are considered to find out the difference of the resulting safety factor. The slope's safety factor should be more than 1.5. Okay, next, proceed to the results. Based on the case study from past research, the data collected have been used to generate the analysis. The dimensions used for the designated slope are 10 meter berm height and 2 meter berm width. The slope will be analyzed with and without the remedial work, which is the soil kneading. This is the parameters of soils that have been used for this study. Different types of soils with different values of cohesion, friction angle, and unit weight. At first, the slope is analyzed without any surcharge load and water table as in figure 3. Then, as illustrated in the figure 4, the surcharge load and water table are added to the slope. The groundwater table that has been set for this analysis is 1 meter. Other than that, a surcharge load of 20 kN per meter cube is applied on top of the slope. The resulting FOS is shown in the table 3 and figure 5. The effect of surcharge and water table make the slope become unstable. The decrease in safety factor is more pronounced in gravel type, followed by silty clay and then clay. This is because the water needs more force to displace the particles in cohesive soils. Next, due to instability, soil nailing technique is used to encounter the problem of the slope. With the aid of soil nails, the FOS of slopes can be increased. In this section, the effect of variation of nail parameters like nail length will be evaluated. Table 4 and figure 6 indicate that FOS increases with nail length. Based on the table, the FOS resulted from the analysis increased from 1.514 to 2.284 for gravel, 1.468 to 1.735 for silty clay, and 1.047 to 1.056 for clay. Hence, when the nail length increases, the FOS of the slope increases. Other than nail spacing and length, bond diameter of the nails also give impact on the FOS of the slope. For next analysis, the spacing is set to be 1 meter and the nail inclination is chosen to be 40 degrees because the FOS increases as the inclination of the nail increases. There are various values of bond diameter that will be used to analyze the slope, as shown in table 5. It can be concluded that the FOS of the slopes increase as the bond diameters of nails increase, as shown in the figure 7. Nonetheless, it can be observed that the percentage increase in FOS with variation of nail bond diameters is not that much in case of gravel and silty clay. Meanwhile, the FOS for clay is constant. Figure 8 shows the analysis of slope by using soil nailing as the reinforcement, which is subjected to water table and surcharge load. There are numerous reasons that lead to instability of slope. Thus, it is vital to analyze the slope to ensure that it is safe and the FOS meets the specific requirement. So based on this study, the cohesion value of gravel is lower than clay. Thus, it can be said that the lower cohesion value of soil increases the stability of the slope. Other than that, it is clearly proved that the FOS is improved when the soil nailing technique is applied. There are some improvements that can be made and some methods that can be explored from this study. Due to insufficient time, this project is only focused on the analysis by using soil nailing technique. This study can be enhanced by recommending other types of remedial work such as retaining walls or introducing other slope stabilization methods such as drainage and berming. This is some references that I use for this study, and that's all from me. Thank you.